In this video, I will show you how to use the properties of parallelograms to find unknown values. Now, in the previous video, we focused on the properties that the opposite sides of a parallelogram are congruent, opposite angles are congruent, and consecutive angles are supplementary. In this video, we're going to add in a new theory, a new property, and that is that the diagonals bisect each other. That means that the diagonals cut each other in half. So if you look at this diagonal, for example, all right, BT, and look at TD. If these diagonals bisect each other, they cut each other in half. So that means that BT and TD will be equal. And that allows us to write this equation. We can say that 7x minus 10 should equal 4x plus 5. And of course, we will solve this by subtracting 4x from both sides, and that will give us 3x minus 10 is equal to 5. And then we add 10 to both sides, and then that will give us 3x is equal to 15. So when we divide both sides by 3, we end up with x equals 5. Now, we need to find each of these lengths. So if I want to find BT, for example, okay, the length of segment BT, well, that is 4x plus 5. So that's going to be 4 times 5 plus 5. So that'll be 20 plus 5. So BT is 25. If I want to find TD, well, TD is congruent to BT. So I know that this will also be 25. No additional calculations necessary. Now, if I want to find BD, well, BD is the whole thing. So if each of these are 25, then BD should be 50. I add these together. All right, take a look at problem number 2, which will be very similar. Okay, so we have to be a little bit careful because we have BD here. And remember that BD is the whole thing. And then we have TD. I'm going to try to color coordinate this as much as possible. And TD is only half. So what we have is a half and a whole. And whenever we have a half and a whole, our equation will be of the form 2 halves equals a whole. Okay, as opposed to the previous problem where basically we had half equals half. This time we will have 2 halves equals a whole. Okay, so 2 times half. Well, the half is the TD. So that's why I will have my 7x minus 12 in here. And this will equal the whole, which is the green. That is the 12x minus 4. So to solve this, we need to do the distributive property. Okay, if I multiply by 2, I'm going to get 14x minus 24 is equal to 12x minus 4. And then I will subtract 12x from both sides to get these x's together. That will leave me with 2x minus 24 is equal to negative 4. Adding 24 to both sides, I find that 2x is equal to 20. So if I divide both sides by 2, x is 10. All right, So if I want to find TD, for example, which is right here, all right, TD is shown here in purple. TD is 7x minus 12, but x is 10, so that makes it 7 times 10 minus 12. All right, so TD is 70 minus 12. So that's going to be 58. All right, now TD is half, and BD is the whole, BT is the other half. So if TD is 58, BT should also be 58. And BD will be the sum of both of these. So that's like 116. All right, looking good. Use only 2 of these to help you get started. Okay, I hear you. Let's see, AT. AT is right here. All right, let's color coordinate as we go. CT is right here. I think that's enough to get started, because those two should be equal. They are both halves. So this is a half equals half type situation. Okay, half equals half. So that means we should be able to write 12x minus 24 equals 8x plus 8. Subtracting 8x from both sides is going to give us 4x minus 24 is equal to 8. If we then add 24 to both sides, then we get 4x is equal to 32. So of course we then divide by 4 and we get x equals 8. All right, now time to find some stuff. Okay, let's start with AT. AT is 8x plus 8. So that's going to be 8 times 8 plus 8. Okay, so that's going to be 72. If you ever get uncomfortable with the numbers, don't forget that you can use your calculator. 8 times 8 plus 8 is 72. Okay, so we have AT. What about CT? Those two are congruent. They're both halves. So those two are congruent. So CT should also be 72. Now, what about AC? AC is the whole thing. So it should be the sum of these. So this should be 144. Okay, now I want to branch over into the other 3 lengths. But for that, I need to switch. Okay, so look at BD. All right, we have an expression for that. So BD is 11x minus 20. So that's going to be 11 times 8 minus 20. So that is 68. So BD is 68. Okay, now in the picture, BD is the whole thing that goes like this. All right, there is BD. Okay, so the other two should be half of that. Okay, because BT is this right here. Okay, that is half. So BT should be 34. It's half of 68. So that should be 34. Similarly, TD is the other half. So it should also be 34 because half equals half. All right, moving on. Okay, QU. All right, so QU is right here. Let's color coordinate. And QS is right here. That is QS. So we have a half and a whole. So we should be using the 2 halves equals a whole framework. So 2 halves equals a whole. Okay, so the half is the blue one here. So that's why I'm going to put the 2x plus 8 on the inside. The whole is the orange one, 5x plus 8. With a little distributive property, I will have 4x plus 16 is equal to 5x plus 8. Then I try to keep the x terms positive. That's why I'm going to subtract 4x from both sides instead of subtracting 5, because that would give me -1, so I like this better. So I'm going to get 16 is equal to x plus 8. And then when I subtract 8 from both sides, I get x equals 8. Okay, and so on this page, they're just asking us to find x, and we don't have to plug it back in to find other stuff. So we're done. We're done with that one, man. Okay, LB. LB is right here. DB. Oh yeah, let me color coordinate as I go. DB is right here. All right, so we have a half and a whole again. Half and a whole. So we should be doing 2 halves equals a whole again. So 2 halves equals a whole. So let's see. The half is the red. So that is 13. And the whole is the green. 2x plus 8. So that means I have 26 is equal to 2x plus 8. Subtracting 8 from both sides is going to give me 18 is equal to 2x. So if I divide both sides by 2, I get x equals 9. All right, not too bad, not too bad. Let's see, SV. This is SV right here. That is a half. Okay, VU. VU is right here. VU is also a half. So we have a half equals half situation. Right? Half equals half. So that means that 2x minus 5 should equal x plus 6. Let's subtract x from both sides. That will give us x minus 5 is equal to 6. Then when we add 5 to both sides, we have x equals 11. All right, we are almost to the end. Okay, so this takes us back to what we were doing in the previous video. Now we're back to angles. And what we've learned is opposite angles are congruent. All right, so in problem number 8 that's coming, those will be congruent. But consecutive angles that are on the same side, these will be supplementary. So these angles are supplementary. They should add up to 180. They are on the same side of the parallelogram. So that means we will have the situation 8x plus 12 plus 104 should equal 180. They are supplementary. Okay, we have like terms here, yes? All right, the 12 and the 104, those are like terms. So if we put those together, all right, so I'm going to bring down the 8x, but then we're going to have 116 is equal to 180. Then if I subtract 116 from both sides, so now I have 8x is equal to 64. So when I divide both sides by 8, I come up with x equals 8. All right, now for the last problem, these angles are opposite angles. And in a parallelogram, opposite angles are congruent. So I can just set these equal to each other. So I will have 2x, no. I have 28x minus 2 is equal to 110. So of course I will add 2 to both sides, and 28x is equal to 112. And then I divide both sides by 28. Four. So that's how you use the properties of parallelograms to find unknown values.